In this problem, we have iron reacting with oxygen gas to produce some iron 2 oxide and some iron 3 oxide. So this is how I set this up, and I'm sure there's an easier way of doing it, and I have a feeling several people, I'm not sure, but anyway, here we go. Some of the iron, of this 20 grams, some of that iron is going to react with oxygen gas, with some of the oxygen gas to produce FeO, and some of the iron of this original 20 grams is going to react with some of the oxygen to produce Fe2O3. We know that we're given that, so I'm going to call this X and Y. X and Y together add up to be 20 grams. And over here, they're telling us that so many grams reacted, but then there was some left over, so 7.47 grams of oxygen gas actually reacted. And we don't know how much of that reacted with the iron to produce FeO, and how much of it reacted with the other iron to produce Fe2O3. So I'm going to call these two other variables A and B. And A and B add up to be 7.47. Now, the two reactions that are occurring, we have one reaction that produces FeO and the other reaction that produces Fe2O3. And I put over here the recipe in terms of grams, so to speak. 111.7 grams of Fe, that's 2 moles of iron, will react with 32 grams of oxygen gas, that's 1 mole of O2, to produce 143.7 grams of FeO, and that's molar mass there. And then on this side, same thing over here. We have 4 moles of iron reacts with 3 moles of oxygen gas and would produce that many grams in total. So I have mass ratios. So now here we go. For reaction number 1, I'll call this reaction number 1 over here. We have this many grams of iron react with that many grams of oxygen gas to give us that. So how are we going to go about doing that? Well, in this reaction number 1, the ratio of oxygen to iron, right, the ratio of oxygen to iron, or I can do it the other way, X over A, this to that. So I would say X over A, right, X over A is equal to 111.7 over 32.0. Right? And as a result, A, if I move this over and divide this, so A is equal to 32.00 over 111.70 times X. I can move that around anyway. And I'm going to be here, I'm going to solve for B in reaction number 2. The ratio of masses between iron and oxygen is this ratio right here. And so in reaction number 2, Y reacts with B. So I could say Y over B is equal to 223.40 over 96.00. And I can solve for B and make this B is equal to 96.00 over 223.40 times Y. So now I have that. So now I have 2 equations and 2 unknowns. And so here we go. X plus Y is equal to 20. And A plus B is equal to 7.47. I have an expression for A, right? 32.00 over 111.70 times X, that's A, plus B, 96.00 over 223.40 Y, And that A plus B is 7.47. So now I have two equations, two unknowns, and now I can go ahead and solve this. I can solve for an expression for y and plug it in here. So for example, 32.00 over 111.70 times x plus 96.00 over 223.40 times y, and y is going to be 20 minus x equals 7.47. And now this becomes algebra, and we go ahead, multiply, divide, distribute, and we get over here, I get 0.2865x plus this right here, 8.594 minus 0.4297x is equal to 7.47. Move terms around and do all the math, and when all is said and done, we get a value of x for 7.85, and that would be grams of iron that reacted in the first reaction over here, and y would be the remaining amount, 12.15 grams of iron that reacted in the second. So that's our x and y value. Now, once we have those, we can go ahead and figure out the masses of each of the products. Let me move this over. 7.85 grams of iron, and this is in reaction number 1. And according to reaction number 1 over here, if you have 111.7 grams, it would produce 143.7 grams. So 111.7 grams of iron would produce 143.7 grams of FeO. We would do that calculation. I lost my calculator here. Where's my calculator? Here's my calculator. 7.85. Let's do this here. I thought I had this already. 7.85 times 143.7 divided by 111.7. That's 10.09 or 10.1 grams of FeO. And in reaction number 2, the 7.85 was our X value. I erased it. And then our Y value was 12.15 grams of iron. I erased the X value. I apologize for that. And then we have grams of iron to grams of Fe2O3. And that's from here, 223.4 to 319.4. So 12.15 times 319.4 divided by 223.4. And that comes out to be 17.4 grams of Fe2O3. Wow. Okay. Let me backtrack over here. When we do this right here, the X value was 7.85. And therefore our Y value was 12.15 for that one. But the final answers is down below. This is a really hard problem.